This lesson centers around the modeling concepts of rules. Our learning objectives are as follows. After completing this topic, you should be able to explain the differences between the default, constraint, and search decision rule classes, also be able to create rules for a model, and also create extensions for rules. Let's get started. Our first section will cover the discussion of rules. This diagram illustrates the next step in the process of building a configurator model and creating rules that define the behavior of the model during configuration. So let's say you decided to simplify the customer shopping experience for a car by providing a set of base option packages. You can prompt a customer to select the right package by using the supplemental structure to capture an answer to the following question. What are you primarily looking for in your car? Price, comfort, or performance? The answer by itself does not provide configuration information for use in the car manufacturing process unless it's first mapped to specific items and options. This mapping can be performed by configurator rules. For this example, you can envision a rule that says if the customer is seeking the car primarily for comfort, a rule should select the luxury package by default. In turn, the luxury package selects options such as 8-way power seats for the seat type, leather as a seat trim, and numerous other compatible options. So, by using the rules, you can help make the configuration process much simpler for end users by shielding them from complexity. This diagram shows how to design the rules that map a selected buying package to options in the item structure of the car model. To model the base option packages for the car, you create an option feature named Base Option Packages in the car model, and then add options to the option feature for each of the individual packages. When a customer selects one of the packages by selecting an option of the base option feature, the rules associated with the option for that package automatically make selections from other options in the structure of the configurator model. Next, we'll look at how to write rules such as these in the configurator model's work area. This section discusses the steps for creating statement rules. You create rules by writing statement rules in the constraint definition language, or CDL for short, which is built into the configurator. The type of a CDL rule is classified by the operator or operation employed. This can be logical, numeric comparison, numeric accumulator, or compatibility. You determine the type of a rule by your choice of CDL operators in the rule text. The class of a CDL rule indicates how the rule is to be enforced during the configuration process. The classes are defaults, constraints, and search decisions. You determine the class of a rule by selecting it in the rule definition. Here are the types of rules. Default rules. These create default selections at the beginning of a configuration session. The end user or constraint rules can override this default selection. Comparison type rules can be used as defaults. By contrast, constraint rules cannot be violated if a configuration is to be valid at the end of a configuration session. Unlike constraints cannot be overridden by the end user or by other constraint rules. All rule types are constraints. And finally, search decisions are rules that are hints to the configuration engine to process certain selections when the configuration. This screenshot depicts how you can create statement rules in the rule editor. To create a rule, you'll use the editor in the area to perform the following steps. First, on the Rules tab of the Edit Models page, you'll create a statement rule by using the Actions menu. Then, you'll select a rule class to govern how the rule is used during configuration. You'll enter the text of the rule's definition language. You can use menus to insert CDL syntactical elements into the rule text. Also, the Validate button checks the validity of the syntax and references in the rule text to make sure that all validation is correct. Finally, the status indicator shows whether the rule has been modified and/or has an error. Any error messages will provide details about any problems with the rules. This next screenshot shows how you can insert model structure references into rule text. Statement rules contain references in your configurator model. The structure pane of the Rules in Editor enables you to access all the nodes of the model for which you are. Both the imported item structure and your supplemental structure are shown. You can insert the correct notation for a model node reference in your rule text by selecting the node in the structure pane and choosing the function called Insert into Rule Text from the context. You can also insert attributes associated with the model nodes in your rule definitions. Here, we see how you can insert rule text with menus and buttons. To assist you in entering the text for a statement rule, a set of menus are available to insert the names, functions, and operators. Hierarchical menus provide access to all members of the categories of function. A buttons enables you to insert the other valid syntactical elements that are required to create a rule, such as comparison, arithmetic, Selecting an option from one of these menus or clicking a button inserts the text shown on that menu or button at the location of your cursor within the rule text. Arguments to functions are not inserted. As a note, you can add buttons as a convenient basic reference to the CDL elements. Our next section discusses extension rules. You create extension rules by writing code in the Groovy language and attaching the code to a model. Extension rules perform the following duties: of rules through code, use the configurator runtime core API to interact with the model, and are triggered by actions in the model during a configuration. Extension rules also enable you to do the following: modify the behavior of the model, obtain a service, and use complex calculations on the model data. There are two components of extension rules: the script code that provides behavior and the elements of the rule that connect the behavior to the model and define when and the code is written in Groovy, which is a flexible and convenient language for using established Java interfaces that provide interaction with configurator models. The connecting elements depend on events, which are or conditions that occur in a model during a runtime configuration session, such as a change in the value of a node. Here are a few examples of events. Post-value change. This occurs after the value of a node is changed. Or post-configuration initiation, initializing a configuration session. Or post-configuration save, which occurs after a configuration, and pre-autocomplete, which happens before the autocompletion process runs. Each extension rule has a base node. When an event occurs on the base node, the extension a specified event, such as a post-value change, is connected to a method in the rule code by an event binding. An extension rule can have multiple event bindings. If a code method has arguments, each argument has an argument binding that provides its values. The general procedure for creating extension rules in the rule editor. To create a rule, you use the configurator model's work area. The first part of creating an extension rule is associating the rule with a model node and adding the rule script that defines the behavior. Continuing, the second part of rule is binding events on the model to methods within the rule script, which is illustrated in this diagram. As previously referenced, Groovy is an object-oriented scripting language for the Java platform. The features for convenience and flexibility of Groovy scripting include automatic import of many Java packages, declaration of variables without declaring their type using the definition, and global variable and method definition. Here's an example of a compatibility rule. This rule ensures that the color, which is a supplemental attribute of the car package, is compatible with the trim color, which is a user-defined attribute, that incompatible options are excluded. For this lesson, you'll create rules for your model, but before we do our practice, let's